Two and a Half Admins, episode 38. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, one of your famous blog posts, Alan, this one about ARM64.
Yeah, so this is a piece about performance on ARM64 specifically. So looking at how you can measure and how good the performance can be on ARM64 compared to x86.
Right, well, link to that in the show notes then. Let's do some news. And the first one, frag attacks, security flaws in all Wi-Fi devices. And this goes back all the way to the very beginning of Wi-Fi and all the way right up to date with the latest Wi-Fi. This is bad.
Yeah, I saw the headline and it was like, this means that several of the newly discovered design flaws have been part of the Wi-Fi spec since its release in 1997.
If you were ever relying on Wi-Fi, built-in encryption to keep your data secure, I got bad news for you. It was a bad idea in 1997. It's been a bad idea every single year since then, including today. So this didn't really come as an enormous surprise to me or make a big impact on my life, to be honest with you. If you want to keep your stuff, relatively secure when you're using Wi-Fi, you need a VPN protocol.
Yeah, and that's one of the lessons we've learned with the first WEP and the first WPA. And the first version of every protocol. And the reason why there's newer versions of those protocols is because it turns out there's been something fundamentally wrong with the protocol and we've had to replace it. It even raises the question of whether we should even be trying to do the encryption at that level in the protocol. It's like, wouldn't it make more sense to use something like a VPN or IPsec or something to encrypt the traffic from the endpoints instead of trying to build it into the Wi-Fi spec? Mostly because we need a way to be able to replace it and upgrade it without having to replace our Wi-Fi hardware. The nice thing about Ethernet is you can change the encryption out without having to change the wires in the walls in the building.
Well, technically, that's the same thing can be true with Wi-Fi. You just have to actually be doing it.
The interesting thing with this one is it has this plain text injection attack, which basically allows you to inject a frame in the middle of a conversation that's not encrypted, and the Wi-Fi devices won't notice and will accept that frame. They have a diagram showing what a Wi-Fi frame looks like and show how one part of it isn't actually protected by either authentication to mean checking hasn't been modified or encryption, so that you can't see what it says. And with this, they can basically trick an endpoint into using a different DNS server, which comes down to if you're using a VPN properly, the DNS will be going over the VPN and maybe it'll work. But it does mean that you have that kind of the bootstrapping problem of they could specifically make the malicious DNS server break your VPN so that you'll give up and try to work without it or something.
That's only if you're configured to ever use whatever DNS server is provided to you by DHCP in the first place, of course. Like, for my own WireGuard stuff, there is no DNS lookup involved in, establishing the WireGuard connection. I've got a raw IP address for the other end of it. And so DHCP can hand me whatever it wants to hand me. It doesn't matter. I'm going to reach out to the same IP address, initiate my WireGuard connection. And, once I've done that, all of my actual DNS lookups are done, via the WireGuard tunnel, to the server on the other end.
Yeah. And, similar thing, much to the chagrin of many network administrators, many phones will ignore whatever DNS server you tell them to use over DHCP and try to directly use Google or something else. And, it can make your life a bit annoying, but it means that some of these attacks are less practical. And so like they say, outside of some unusual network configurations, a lot of the problems they found here are not that easy to exploit. But as people look into it more, they might find more and more ways to be able to do this.
Yeah, these flaws do look kind of difficult to exploit, but, ultimately you're still talking about, well, in some cases, we can see some of your traffic plain text and we can inject plain text into your traffic. And even if that's only every once in a while, that's a pretty bad loss for what's supposed to be an end-to-end encrypted protocol.
For sure. And, a lot of it apparently comes down to programming mistakes made in the Wi-Fi protocols or the products themselves. So in some cases, a mistake made by the developers where they didn't quite follow the spec well enough, or mistakes built into the specs. And, we've seen both of those happen before. And The hard part is that it's not going to be easy to replace some of this stuff. Some of it, a firmware update maybe solves it. But for some of these, it's going to be, rip out and replace your access points, and that's never fun. And
those firmware updates are definitely going to get applied to all the network gear in the world, especially the low-end consumer stuff, eh?
Yeah. And, you have the other question of how is that firmware verified? Am I actually turning out that I'm installing the real good firmware, or am I installing, supply chain attack firmware that's going to make my router worse?
Well, usually the way you can tell the difference is the real firmware does not even claim to apply any security patches because they want you to buy a new device for that. So if the firmware says it's actually addressing security issues,
it is suspect.
It's pretty sus. As far as the impact of, frag attack itself, imagine you've got a bathroom door that only turns transparent for a second or so every once in a while. Like, maybe it's pretty difficult to exploit for exactly what you want, but it's still not something you want in your house.
The other thing I found interesting here was how long the embargo period on this was. The researchers waited 9 months after reporting this problem to the vendors before talking about it. And apparently the disclosure was supervised by the new Wi-Fi Alliance, the ones that decided to call it Wi-Fi 6 instead of 802.11
AX.
Yeah.
But the clear solution here is just to make sure everything's wired and Ethernet, and then problem solved, eh?
Or again, just, use a proper VPN protocol.
Yeah.
Never trust the Wi-Fi. If you didn't trust the Wi-Fi in the first place, this wasn't a problem for you. If you did trust the Wi-Fi in the first place, you already had a problem.
Well, if you trusted the Wi-Fi in your own house or your own business?
No. I do not trust the Wi-Fi in my own house or business. It is suspect as hell. If there is something that I do not want getting messed with by arbitrary bystanders, it does not go over, Wi-Fi alone. You're going to have to protect it with, WireGuard, Nebula, or God help you, OpenVPN tunnel. You'll find that in enterprise already as well, and for the same reason. Or even I think 15 years or so ago when I was attending the University of South Carolina, they required an OpenVPN connection over the Wi-Fi just for anything, whatever you wanted to do. The university infrastructure would ignore every single packet to anything but their OpenVPN server. So if you wanted to get on their Wi-Fi, you also had to have OpenVPN credentials. And that's the right way to do it.
Yeah. In the end, the Wi-Fi is broadcasting stuff over the air. A lot of the stuff you're going to end up talking to now is probably going to be over TLS, like HTTPS, but not everything. And so a VPN's the best way to solve that.
Yeah, it's not just that it's broadcast over the air. It's broadcast over the air on a protocol that was never really designed for anything other than good enough.
You can tell from the name of the very first one, WEP. It's like, this is meant to give you the same level of protection as if you were sending it over a wire someone could tap.
Yeah.
Right? It just means it requires a non-zero amount of effort. But 0.0001 is still a non-zero number.
Yeah, but when people design SSL or OpenVPN or WireGuard or Nebula, what have you, the goal there is no kidding, everything is encrypted and you cannot get in, and we're serious about it. The entire world might have access to this encrypted data stream, and we expect to protect it from the entire world that might have access to it. Whereas Wi-Fi encryption has only ever been designed to be just good enough, with the idea that, well, you'd have to be right there on top of it anyway, so, it'll probably be fine.
You would definitely notice someone lurking around for months trying to get the key, right?
Would you? If you're in a business, there's neighboring businesses, they have parking lots and, people park in them.
Yeah. And, I have a Wi-Fi device that's less than half the size of a deck of cards that I could have enough battery to sit there and listen to Wi-Fi stuff for weeks. And then I could come back and swap it out with a fresh battery or whatever and eavesdrop for a long time. I don't have to actually be standing there wearing my black hoodie with the hood pulled down to be a hacker.
Which we kind of shifted points there, and it might not be too clear. We started out with the point that Wi-Fi was only designed for security that was just barely good enough. And what Alan is saying now, and he's completely correct, is it never really has been good enough.
So yes, use a VPN.
Okay, this episode is sponsored by Linode. Go to linode.com/2.5 to get started with $100 free credit and 60 days to use it. Linode offers cloud computing solutions in data centers all over the world. Whether it's scalable VMs with a choice of major distros or one-click apps and stacks, dedicated CPU and high RAM instances, block and object storage, or cloud firewalls and DDoS protection, Linode has everything you need for your personal projects right up to managed enterprise infrastructure. I recently moved my website over to Linode and it was really straightforward. And when I needed a Mumble server for our Late Night Linux community meetups, spinning up a new VM for that was an absolute breeze. Everything's been running flawlessly since I set it up, and I love the peace of mind I get from the automatic backups. So go to linode.com/2.5, get your $100 credit, and check out Linode's great cloud hosting services and first-class always available support. That's linode.com/2.5. Let's talk about IBM and their claim to have the world's first 2-nanometer chip.
Well, the first problem with that is how do you define a 2-nanometer chip to begin with? An order of magnitude ago, when process sizes were, like 20 nanometer or 40 nanometer, that referred to the actual length between the gates on a transistor. But that has not been the case for a long time now. There is no more real process size as defined clearly by anything. When TSMC or AMD or Apple or now IBM say, a chip is 10 nanometer, 2 nanometer, 7 nanometer, or whatever, it's basically just an arbitrary number. They say that it's a 2D equivalent, but chip design is three-dimensional now, and it probably makes more sense to compare the actual peak transistor density on the most heavily populated area that you can manage with a particular process.
Yeah, I was just looking at that table and noticing that some 10 nanometers have a higher density than some 7 nanometer CPUs.
Yeah, it does, and there's still a lot of room for contention there as well. Intel has been claiming for a long time that their processes are more advanced than they looked. I guess basically they're saying they picked the wrong bogus numbers to claim for their process size. Because then they say that, our transistor density is actually, for at 10 nanometer is about the same as AMD's is at 7 nanometer. But again, it's important to realize what you're actually talking about, which is not necessarily the actual transistor density, you see averaged out across an entire processor. It's the peak possible transistor density. And in fact, most areas of most integrated circuits are not going to be anywhere near that dense. You'll usually see the highest density in something relatively simple, like a RAM chip.
So you're telling me Intel's department who came up with that number is the same as comes up with the TDP numbers then?
I don't know that it's the same department, but they may have some of the same mentors, let's put it that way.
Yeah. I would just say equally meaningless.
Although in this case, the hilarious thing is that, apparently they went too high with their bogus number. They should have gone lower with it. But yeah, a lot of people will argue, that both ways. The Intel fans will say, "Oh, well, you don't understand. A Sunny Cove 10 nanometer chip, it's about equivalent to TSMC's 7 nanometer process." Others will say that's greatly exaggerated and that's not true, and 10 nanometer really is 10 nanometer. I think I'm probably more inclined to believe Intel's claims that, hey, this is our transistor density and it actually is pretty comparable. And the reason I say that is just because of how well their laptop chips have actually been managing to compete in the last few cycles. If their process weren't able to produce about the same peak transistor density, I don't think they'd have been able to get as close to on par with AMD performance-wise as they have been.
Are they on par with them, though?
On the laptop side, yeah, they're real close. On the desktop side, oh, hell no, because the desktops are they're still stuck on 14 nanometer on the desktop. On the laptop side, it's a lot closer. The AMD processors, they do have, higher core count, higher thread count, but you're still looking at pretty much parity per thread. When you're looking at like the flagship parts in the latest generations between Intel and AMD, it's really difficult to just absolutely pick a winner and say, oh, well, this is the best one. Because the Intel chips lately do tend to be a little higher performance and, very lightly threaded workloads. The AMD parts usually win in massively multi-threaded workloads, but that's assuming that, you're buying the flagship AMD part with tons of cores to begin with, and that you're trying to do that workload on a laptop, which most folks really aren't. But for something that's only a little multi-threaded, like gaming, gaming will pretty easily go quad thread and sometimes octa-thread. And it's about even up there. So now you're looking at, okay, well, whose iGPU do I like better if I'm using the integrated GPU? Or, who's gotten the marketing deal to get themselves in the chassis that I want from the manufacturer that I prefer.
Yeah, like you can't get an XPS 13 with AMD, for example, and that, I think, is one of the most attractive chassis.
I'm not as big a fan of the XPS 13 personally. I mean, it's definitely a nice laptop. Don't get me wrong. I'm absolutely not crapping on it, but I find it rather pricey, and I don't know. I'm not as big into the quote design unquote fetish. Like I'm never going to be an Apple fan because of whatever feelings, the white chassis and the Apple logo give me, or whatever it is that Apple folks really like about their stuff. I've never really understood it. I'm actually a big fan of Acer. When you just want something that's got, solid performance and gets the job done and doesn't cost much money, man, they've got a hell of a lineup.
Is this new IBM chip going to eventually be like a Power 9 thing? Or like it sounds like it's just an IC at this point?
Yeah, it's just an IC at this point. They built a prototype functioning chip using that process. They didn't even specify what it is, but it looks like it's probably some kind of prototype RAM. I mean, literally just from looking at what the wafer looks like.
Right.
So they just wanted to get some headlines, essentially.
The thing to realize here is that IBM hasn't actually been a manufacturing company for a very long time. The major focuses of their business at this point are consulting and research and design. And this falls on the R&D side. They absolutely got some patents out of this process, and they have partnerships with Samsung and Intel, who I'm sure they are looking to, throw some sweet licensing money their way to use some of this new technology, a few years down the line.
Yeah, don't forget buying Linux distros as well.
Yeah, I'm not quite sure where that falls into the pattern. Honestly, I think IBM bought Red Hat hoping that the tail would wag the dog. I think they were looking for, an injection of new blood. That, were worried they were getting a little too hidebound. That may not be the case. It's wild speculation, but it's wild speculation a whole lot of folks in the industry have made about that.
Yeah, they needed something that was a growth opportunity and to pair with their cloud stuff and just to give them a direction.
Okay, this episode is sponsored by CBT Nuggets, training for IT professionals or anyone looking to build IT skills. Go to cbtnuggets.com/25admins and sign up for a 7-day free trial. I've just started my learning journey with CBT Nuggets, but I've already picked up tons of knowledge from the short and manageable videos in the Docker and Network Fundamentals courses. Their in-house trainers are active and certified IT professionals who add around 40 hours of new training to the course catalog each week, so you can always stay current and up to date. So start your free 7-day trial today at cbtnuggets.com/25admins. It includes unlimited access to all course materials, including virtual labs. That's cbtnuggets.com/25admins. Let's do some free consulting then. If you want to send your questions in for Jim and Alan, you can do that via email, show@2.5admins.com. And thank you everyone who supports us with PayPal and Patreon. We really do appreciate that. You can go to 2.5admins.com/support to find out more about that. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. So we have got 2 questions that are very much related. Mika says, give me a sales pitch on why I shouldn't buy Synology. Anyone better? And Chris says, Jim says that Synology NASes are optimized for low manufacturing costs. I can definitely see that, as there are areas where the engineering of the hardware is suboptimal. One of the things I love about Synology software, though, is the convenience. Their Hyper Backup package that comes with them lets me set up 2 backups, one to an external USB attached hard drive and one to Backblaze B2 in a little over half an hour. Are there any similar solutions in the FLOSS/DIY NAS space that don't involve custom shell scripting and dealing with that godforsaken crontab file I've been warring with for the last 30 years?
Well, I'd say the first thing is any kind of off-the-shelf product like this is geared towards people that don't want to know how it works and don't want to do anything outside of the couple of things the UI is meant to let you do. And it's always a trade-off of going for something that is built in to do a couple of specific things and does those versus something that's more flexible unless you do what you want, but requires you to know more about what you want to do And sometimes it's just a matter of deciding where on that scale you are and choosing the option that's best for you.
I don't feel like the off-the-shelf NAS really fits any of the use cases that I encounter all that well, because it's they're built as though they're aimed at like end user consumers. But how many end user consumers do you know that want to have a box with 8 hard drives packed into it, sitting in the corner of their house or, in their office or whatever? You kind of have to know too much to be able to use one of those NASs for one of those NASs to be a great idea. By the time you've invested the expertise and the money and the hardware and the time and, getting a 4 or an 8 bay NAS from Synology or Netgear or QNAP, you could easily have just built a generic PC and put those hard drives in it and, installed a distribution like Sigma NAS, and you would have a more powerful, more flexible machine that you could, actually repair easily. Because that's another issue. When the board dies in your Synology, 4 or 8 bay NAS, what do? Well, you probably just go buy a new one. I mean, even if you're getting it repaired under warranty, are you going to ship the thing back? I mean, it's ugly. There's no easy way out of that.
Your NAS can't be down for a month while you wait for the replacement to ship all the way to somewhere and then come back and so on. And so even if you get it repaired for free, you're still buying another one in the meantime. And then are the hard drives going to just slide in nicely, or is the new chassis got different things? And then this doesn't work, and it can't reconstruct the RAID volume. And it's, oh my God. So yeah, I think like Jim said, the Synology is kind of meant for the office that doesn't have an IT guy.
Yeah.
Which thinks they need a file server, but because they don't have an IT guy, they're never going to use it effectively anyway. And so it's never going to be a problem because it's always going to be their fault for not having an IT guy.
But isn't it a case that if you buy a Synology and plug it in and go through the instructions that they give you and put your disks in and it's all set up, Windows will just see it on the network and will offer to back up every night to it or whatever. And okay, that's not ideal and testing backups and all the rest of it, but that's surely better than just having nothing.
I mean, Windows isn't just going to be, oh, sweet, there's a NAS. You want me to back up to that? That's not how that works.
No.
That would be pretty neat. If that was actually the case, I might be a little bit more positive about the product. But no, man, you're going to have to set up that NAS. You're going to have to put all the drives in it. You're going to have to get it booted up. You're going to have to pick a topology. You're going to have to let it format. By the way, the way those things work, it's probably going to be in a pretty low performance profile for a couple of weeks if you've got sizable drives and 6 or 8 of them while you wait for the the lazy format on ext4 to catch up with everything, or Butter in this case, and MD RAID has its own lazy allocation to work with. But I'm kind of getting away from the point, which is, you've got to do some fairly technical things to get this thing set up to begin with. And even then, once you've done that, it is literally just a machine on the network offering a Samba share. You still have to go out and find it from any of your Windows computers and do whatever you want to with it from there. You've got to create shares on it. I mean, we weren't even really done yet. We added the drives and we set up topology and we built the array and we let it start formatting. We also needed to create shares. Now we need to go find those shares on the network from our Windows or our Mac boxes or whatever. We need to configure it to do the backing up or to just use it as, a shared drive or whatever it is that we want to do with it.
And then you got to convince everybody in the office to store the files that are important on the NAS and not their damn computer.
Yeah.
So that everybody can access them and so that they get backed up from the NAS.
None of this is simple and easy. You basically need to be, you don't need to be a full-time professional IT person to set all this up, but you've got to at least be a pretty competent hobbyist. By the time you know enough to set all this up, you easily know enough to set up a Sigma NAS box.
Or even just like my one, which is just a generic x86 box with Ubuntu installed on it and Samba.
Yeah, Sigma NAS is easier than that, and you do get some things out of that you definitely will not have set up on your vanilla Ubuntu box. But either way, your point is correct. It's easier just to start out with generic hardware and just do the thing. It's easier, it's more flexible, it's more repairable.
It's probably cheaper as well, right?
Typically, yeah, it's going to be about the same cost. It can be a little bit cheaper. It can be a little bit more expensive. If you're starting from scratch and using all new hardware, I can usually get to pretty much the same cost or less as an 8-bay, Synology or Netgear NAS with x86 hardware with, double, if not quadruple the RAM and vastly more powerful processor. Now, one argument you can make is that these things are usually going to have, very power efficient ARM CPUs in them, which is a double-edged sword. It means they don't have enough CPU to do anything at all, but, just like hand you your files. But it also does mean that, they may have a slightly lower electrical power profile than something that you built yourself.
But yeah, you can optimize it whatever you want when you build it yourself. When you're buying off the shelf, it is what it is. And, if it turns out to be not quite enough CPU, then you're pretty screwed. The last question there was about backup stuff. Like, I know some of the things like Sigma NAS have plugins for things like Backblaze to back up. And then, for an external attached hard drive, I don't know what the Synology is doing. But, we've talked plenty about using ZFS replication to take backups on an external hard drive and how it can be much faster than most other backup types because ZFS is keeping track of what's changed and what's not in a much more efficient way than your normal backup tool, having to crawl the whole file system and examine every file to see, hey, when was the last time you were modified?
Yeah, it also just kind of weirds me out a little bit when we talk about, 1, 2, and external USB attached hard drive. I'm like, if you can fit everything on one hard drive, why do you have a NAS to begin with? Like, you don't have the problems that you need a NAS or a big server for. And
I guess the last thing is that my biggest peeve with Synology is the fact that it's this weird concoction of MD RAID or whatever and Unraid and ButterFS and so on. And it's just like, even if it isn't going to be ZFS, I want something that's going to be relatively easy to work with from a rescue system of some kind. Just a vanilla, Ubuntu CD or live disk and be able to access the files if I need to, if the hardware goes tits up. I don't want something that's really weird and esoteric and just a pain to work with.
It's actually not that weird. The way those things are set up, it basically boils down to it's Butter sitting on top of LVM. Depending on how you want to describe it, you could say MD RAID and LVM. But that's gotten kind of incestuous in the Linux world over the last few years. So basically, either way, you're talking about Linux kernel RAID and Linux volume management, and then that's presented as one single big volume to format with the Butter file system. So it's actually not that hard to get up and running in a rescue scenario as long as you've actually got a box handy with enough bays to put all those drives in to begin with. And if you had that, then I'm questioning again why you bought the Synology, because you could have just done the thing. And
we won't get into today about the fact that you're having to use Linux kernel RAID to feed it to ButterFS because ButterFS's RAID can't be trusted to keep your files intact.
Well, yeah, and the biggest argument for Mika, who said, give me a sales pitch on why I shouldn't buy Synology, is ZFS, right?
Or the reason why you shouldn't buy a Synology is ButterFS.
Well, yeah.
But yes, I think that the bottom line is because I'm not going to help you with it when it goes wrong.
In the way that Synology and Netgear are using it, Butter is not really the problem here. Because again, as far as Butter's concerned, it's a laptop. It's an unusually large laptop. It's got a single volume, and Butter has proven itself quite stable in that, environment where you're basically asking it not to need to be a next-gen file system. You get a few snapshots out of it. There are some performance issues with maintaining snapshots. Welcome to Butter. The real question is just why they bother with Butter to begin with. And I don't know the answer to that question because they could have gotten the snapshots just as easily and frankly just as performantly out of LVM itself. They didn't need Butter for that.
Right. And it's not like they're doing the cloning and stuff because they don't expose that to the user in a way they're not going to be able to use. It's not the target audience of a Synology in the first place.
Correct.
So I agree. I don't understand why they're choosing Butter there.
What about bit rot protection?
You don't have it because as far as Butter's concerned, there's only one copy of every block.
Right.
Now, you do have, I don't know how much I trust it, but most of these devices seem to have turned on the DM integrity patch for Linux kernel RAID, which means that there is, at least in theory, some bit rot protection. I just don't know how much I trust it because we're not talking checksums. With DM integrity, basically, you're checking to make sure that each block in the stripe adds up to match the parity for that stripe. And if it doesn't, then you can go through and do like some differential analysis to figure out which one of them is bad. and then you can do something with that.
Yeah, it's more protection from the write hole than it is a solution to bit rot.
It works equally well for either.
Mm-hmm.
But I don't know how much I trust it, and it has some pretty serious performance implications.
Yeah, that was the thing that surprised me most about LVM when I was at the, I think, Open Source Data Center conference in Germany or something, and somebody was talking about using LVM snapshots for an SQL database. And they're like, yeah, when you take the first snapshot, expect performance of the file system to go down by half, and then each additional snapshot will take off like another 20%. I'm like, do I have some this great product that I'd love to sell here?
Right, well, we'd better get out of here then. Remember, show@2.5admins.com if you want to send any questions for Jim and Alan. You can find me on Twitter @Joe Ressington.
I'm at JRSSNet.
And I'm at Alan Jude.
We'll see you next week.